Today, we're talking about a really profound shift happening in the world of AI infrastructure. Seriously, it's huge. We're moving from AI that can just find answers for us to AI that can actually take action. And you know what the key to all of this is? It's not some fancy new model. It's the database.
Think about it. For the last couple of years, AI has been amazing at describing things, right? It can summarize a document, answer a tough question, even write code. But what happens when that AI can start doing things all on its own? That's the leap we're going to explore.
And really, this isn't just a small upgrade. It's a full-blown evolution. We are going from these reactive AIs that just sit there and wait for our questions to proactive agents that can tackle complex goals all by themselves. So, what's making this possible? Again, it's not the model, it's the database. Things like PostgreSQL with pgvector are going through a total transformation. They're no longer just simple storage warehouses for documents. They're becoming the mind and the memory for these new autonomous AI systems.
Okay, so to really get where we're going, we first have to understand where we are right now. Let's call this Generation 1, and the best way to think about it is as the AI librarian. It's all built on a process you've probably heard of called Retrieval-Augmented Generation, or RAG for short.
So what exactly is RAG? Well, it's the system most of us use every day. To put it simply, it's a process where the AI doesn't just guess an answer based on its training. No, it actively goes out and fetches relevant, up-to-date documents from a database to build a much better, more accurate answer for you.
And honestly, this is the perfect metaphor. Gen 1 AI is like a brilliant librarian. You ask it for information, and it knows exactly which book or document to pull off the shelf to find you the perfect answer.
And this process is pretty straightforward, right? It's a simple linear flow. You ask something like, hey, what's our company's policy on remote work? The LLM queries the database finds that policy document, and then the LLM reads it to give you a nice, neat summary. It's reactive, it's simple, and for answering questions, it works great.
But here it is. This is the wall we've hit with Gen 1. The AI librarian can tell you all about the deployment policy. It can explain every single rule, but it can't actually run the security scan for you or notify the team that the deployment is starting. It can describe, but it cannot act.
So if Gen 1 was the librarian, then Gen 2 is the project manager. This is the beginning of what we call agentic AI. These are systems that don't just answer our questions, they manage and execute entire projects from start to finish. Just look at this comparison. It makes the shift crystal clear. The librarian finds a document and gives you an answer. The project manager, on the other hand, is given a high-level goal, and then it takes multiple proactive steps to actually get it done. The outcome isn't just information anymore, it's action.
And here's what that looks like in the real world. You're not asking the Gen 2 agent how to deploy something. No, you just give it a command. Deploy feature X to production. The agent is then responsible for figuring out and running through all the necessary steps to make that happen.
And this brings us right to the heart of this whole revolution, the brand new role of the database. It's not a dusty old index of files anymore. It becomes a living, persistent memory, a true digital brain for the AI agent.
Remember, in the Gen 1 world, the database was just a lookup table. It was static. You asked for a fact, it gave you the document with that fact. End of story. But now, in the Gen 2 world, it is a whole different ballgame. The database is a proactive, semantic memory. It doesn't just hold facts. It stores experiences, successful plans, what tools are available, and even what failed in the past. It's what the agent consults to decide what to do next.
So the process is now a loop, a cycle. First, the agent dips into its memory to find a learned strategy. Then, it finds a proven plan that has worked before. After that, it queries its memory again to find the right tool for each step in that plan. And finally, it executes the step, and this is the crucial part. It learns from the result, storing that new experience right back into its memory. So what's actually in this memory? It's not just PDFs. It's learned strategies, sequences of steps that are proven to work. It's a tool store with descriptions of every API the agent knows how to use. And most importantly, it's the agent's own history of successes and failures, which it uses to get smarter over time. And this is why this is such a big deal for anyone working in tech infrastructure. Your job is no longer just managing data storage. You are, and I mean this quite literally, designing the schema of an AI's mind. You're building the very framework that lets it plan, remember, and learn. Now, as you can imagine, as these agents get more complex, connecting them to dozens of different tools, Slack, Jira, you name it, can turn into an absolute nightmare of custom code. That's where a new standard comes into play, the Model Context Protocol, or MCP. Honestly, this is the perfect way to think about it. MCP is basically the USB-C port for the world of AI agents. It's one universal connector that just simplifies everything.
MCP handles all that messy wiring. It creates a standard way for any tool to plug into the agent. And what that does is free up the agent's brain, the database, to focus on what it does best, being a high-performance memory, instead of getting bogged down with custom code for every little tool.
Okay, let's bring this all home. As we move into this new world of agent AI, the most critical work, the real frontier, is happening at the infrastructure level. Because you have to remember, without a sophisticated memory, true autonomy is just impossible.
This quote just nails it. An agent's ability to act on its own is completely tied to the quality of its memory. How fast, how reliable, and how well structured that database is. That's what's going to determine how smart and capable the agent can actually be. So if you take one thing away from this, let it be this. The real magic that turns a simple Q&A bot into an intelligent, autonomous agent isn't just in the LLM. It's in the infrastructure, the system that allows it to remember, to learn, and to act.
And that leaves us with one final big question to think about. As AI evolves from a tool that gives us information into an agent that takes action, the most important job changes too. The question is no longer just about who trains the model, but in this new age of agents, who builds the mind?